aerospace industry is key to national economies around the world. Leading aerospace companies recognise that investment in technology and innovation is vital to success and growth. Here at the University of Exeter, our research tackles these industry challenges and seeks solutions to advance the companies that we work with.
The University of Exeter has got capability in the aerospace sector in a wide variety of fields. We can do materials for aerospace, especially in materials for inside airplanes. We can do additive manufacturing for aerospace. We also look at supply chains, so manufacturing supply chains that feed into the companies which make aeroplanes themselves. We have lightweight structures to actually go inside the aeroplanes to make them lighter and more fuel efficient, and capability on control of aeroplanes and rockets. We also have expertise on energy harvesting, so that's powering wireless sensors and monitoring systems to go on board aeroplanes. And we are working with a big industrial partner on wear problems in gas turbines.
A good example of aerospace materials we're working on are the new generation of thermoplastics for aerospace based on polyaryl ether ketones, or PEEK, the PEEK family of plastics. They make very interesting and advanced composites. Airframe makers are fascinated by these materials because of their lightweighting potential. They are 40% lighter than aluminium and potentially 70% lighter than steels. They do not corrode. They are highly heat tolerant, up to 250 degrees. And one of the most important factors is that they are tough. Well, the PEEK family of composites are already used on around about 15,000 aircraft. And it's a qualified material, being qualified by both of the world's main airframe makers, Boeing and Airbus, and is also qualified for military applications. Exeter is uniquely positioned and has geared itself up to be able to process PEEK parts via things such as extrusion, injection molding, compression molding, and additively manufacture, so that we can process PEEK parts in several different ways.
So in my laboratory we do a lot of fun stuff with aerospace structures, lightweight materials and structures for aerospace. We do a lot of modelling and design, so that's our real area of expertise, but we also do prototyping and testing. My work in lightweight structures is really impacting in industry in delivering new solutions, especially lightweight solutions, to key components, especially where there are other problems too. So I like to tackle multifunctional problems, multi-physics problems where I'm designing lightweight structures that have load-bearing capacity, excellent load-bearing capacity, but also tackle problems like vibrations. So I can put a vibration damping capability into my lightweight structures, and that's novel, that's unique. We're working with Rolls-Royce on wear problems. Now this is a particular kind of wear that happens when vibrating components are in contact with one another. We're helping to develop some better prediction tools. Now prediction tools are very important for companies in aerospace because they need to know when components in an engine, let's say, need to be inspected and possibly changed.
The worst case analysis tools that has been developed at University of Exeter has significant impact in the aerospace industry. The worst case analysis tools are used for validating the control laws of space systems.
So the university wants to work with industry, we want to collaborate with industry on real world problems. So we need to be out there with industry tackling the problems that really matter right now. We are taking what we call an open innovator approach with collaborations with industry, and that means we want to be fast and efficient. We will have sensible policies on IP, sharing IP, ownership of IP and revenues, and we will look to co-fund wherever we can. So we were happy to work with the big primes, the Airbuses and Rolls-Royces and GKNs of this world, right the way down the supply chain to the SMEs. We want to work with everyone.